Okay, today we're looking at the powers of monomials. Powers of monomials means that we're going to have something inside parentheses raised to a power. It's kind of like you're using a rubber stamp and doing the same thing over and over and over. So we're going to first rewrite this as a multiplication problem, then we're going to expand it in simplified form. So the first one here says m to the third power raised to the fourth power. So we're going to take care of the one on the outside first. So that means we're going to have m to the third times m to the third times m to the third, and then again m to the third. We do it 4 times, that's the fourth power. Then we go through and expand each of these. So I'm going to have 1, 2, 3, that takes care of the first one. Then I'm going to have 1, 2, 3, the second one. 1, 2, 3, that's the third one. And then 1, 2, 3, the fourth one. Now it's a matter of seeing how many m's do I actually have. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So my final simplified answer is m to the 12th power. All right, so looking at example 2 here. In example 2, I have negative 4mn in parentheses raised to the third power. So that means we're going to do negative 4mn times negative 4mn times negative 4mn. So this means I'm just going to do negative 4 times m times n, negative 4 times m times n, and negative 4 m n. I want to take care of my numbers first. So I'm going to multiply negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4 is a positive 16 times my negative 4. And negative 4 times 16 is a negative 64. So I now have negative 64. Go and collect my m's. So I have 1, 2, 3 of those. So I now have m to the third power. Collect my n's. There's 1, 2, 3 of those. And then I have n to the third power. So my final answer is negative 64 m cubed n cubed. Looking at example 3. In example 3 here, I'm going to take all the stuff that's inside the parentheses and do it 4 times, because that's my exponent on the outside here. So I'm going to have 4a cubed b squared times 4a cubed b squared times 4a cubed b squared, and then one more here, 4a cubed b squared. Next I need to expand each of these things. So this expands to 4. I have a 3 times, b 2 times. Next I have 4, a 3 times, b 2 times. 4, a 3 times, b 2 times, and then lastly I have 4, a 3 times, b 2 times. Again, let's take care of our numbers first. So I have 1, 2, 3, 4 4. So I'm going to multiply 4 times 4 times 4 times 4. I can do these in groups. This gives me 16 times 16. 16 times 16 is 256. So I have 256 Collect up all my A's. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a to the 12th power. Collect all my B's. So I have 1, 2, 3, 4, 5, 6, 7, 8. And there are 8 B's, so B to the 8th power. And that's our final answer. 256, A to the 12th, B to the 8th. Example 4, we have two different ones we have to go through and start expanding out. So we're going to start with the first one right here. This one here. So I'm going to do 1 over 3 P Q, 1 over 3 P Q. Then I'm going to expand the second one here. So it's going to be 3 P cubed, Q to the 4th. And then a second time, 3 P cubed, Q to the 4th. The first ones, there's nothing to expand, so I just rewrite them. 1/3 PQ, 1/3 PQ. I now need to start expanding these, so that's 3 and then we have 3. Whoop. That's supposed to be lots of P's going on here. Gotta give P's a chance. Then we have 3. Looking at this, I have gone through and left a lot of pieces out. So it just shows you have to pay attention to what's going on. My exponent here was 3, so I should have had 1/3 3 times, 1/3 3 PQ 3 times. So I need to go and put that back in there. So I need another one. 1/3 PQ. And I should have had one up here, 1/3 PQ. And then here, I left out of this section all my Q's. I left out of this section all my Q's. And this section here all my Q's. So I need to go back and put a lot of Q's in here. But I also put too many 3's and P's. So I need to go clean some of this up. The hardest part to do about any of these types of problems is paying attention to what's going on and not losing pieces. So I only needed 2 of these, because there's only 2 here. 1, 2. But I do not have Q's to go with these. So I need 4 of them. 1, 2, 3, 4. And then I need 4 for my other one here. So I need 1, 2, 3, 4. Now I have all my pieces here. I need to go through and collect my numbers first. Looking at my numbers, I have 1/3, 1/3, 3, 3, and 1/3. That's what I need to be multiplying together. So I have 1/3 times 1/3 times 1/3. I have 3 of them because now that I have it corrected. And then I have times 3 times 3. We can multiply, these are like saying 3 over 1, so we multiply straight across and we get 9 over 27, which reduces to 1 over 3. Our numbers have been now taken care of. I need to go through and collect all my P's, and I got P's all over the place, and we're going to give P's a chance. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 of them, so there's P to the 9th power now. P to the 9th power. Got to go collect all my Q's. It's always good to mind your P's and Q's. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 Q's. So that is Q to the 11th power. And there's our final answer. 1/3 P to the 9th Q to the 11th. Again, it shows how easy it is, and if you're not paying attention to all the parts, it's easy to lose some of these pieces. We have one last example here, example 5. Example 5. Let's go through and expand these things. I've got to take care of that part first. My 5 here, he's just going to be chilling out front. This is now 2x cubed y times 2x cubed y. And I double check, yes, I should only have 2 of those. So I now go through and start expanding this. My 5 is hanging out here, times 2 xxxy times 2 xxxy. I now multiply my numbers. My numbers are 5, 2, and 2. So 5 times 2 times 2. This gives me 4 times 5, which is 20. I now gather up all my x's. There's 1, 2, 3, 4, 5, and 6. So I have x to the 6th power. Then I have 2y, so that would be y to the 2nd power. You need to pay attention to what's going on, keep track and pay attention to our exponents here, and make sure you count all the pieces and parts. Good luck dealing with our powers of monomials.